Hamza, I've shared your sheets also. So if you all want, you can open up your checked answer sheets also.
Ma'am.
Just check whatever mistakes are there. Yes, Hamza.
Ma'am, I was uploaded, but only 1 and 2 question I uploaded. Others I wrote, but by mistakenly it's just uploaded 1 and 2 question.
Okay, that incomplete which I have written. So why didn't you share it?
I wrote up to 7. I wrote answers,
Okay.
but by
So
mistakenly I
do
just
one thing,
uploaded
Hamza. Whatever is left, just click the picture and share it on the WhatsApp. Because now once it is gone, you're not able to upload it. Huh?
Yes, ma'am. That's the problem.
Because I think that option vanishes once you upload one assignment. WhatsApp pe bhej do, I'll just check it. It will give me an idea. Okay, rest of the assignments were good. Maha's also have checked it back. So Maha, Nabil and Hamza, yours are checked. Ikra, you also submit. So yes, so class, when you have the equation, I think the best equation to use here is S is equal to ut plus half at square. Initial velocity is 0. This is half 3 into time is 35 whole square. I think this will come out to be 187.5 meters. Right? This is the answer, I think. Just cross check it someone. And it says velocity of the jet at takeoff. See, initial velocity is 0. Okay, this is like this. Oh, 37, I think. 1837.5.
Yeah, it's 1837.
37.
Yes,
No? 1837.5. So see, when it is initially at rest and it has started movement, means moving. Now, what happens after it moves? That isn't part of the question. It could have exceeded that also, right? So we are not concerned with how it is moving. We are just concerned with that this will be the final velocity in our system. What's our system? The aeroplane moving till here, and when it takes off, it is the final velocity on the ground. So everything is with respect to the ground for us. So don't get confused that it is taking off. So you have to calculate everything in terms of this is not motion under gravity equation. Simply v is equal to u plus at would do good here. Initial velocity is 0, acceleration is 3, time is 35 seconds. This is 105 meter per second. Okay. Write it quickly, those who have not written it. Then I'll discuss the second. And this text done also so that I can move forward.
Ma'am, I had a doubt in the last physics test, the last question, 8 months.
Okay, your physics test was this week only, no?
Last week, yeah.
Papers are checked?
No.
So I have not received your paper. Let me get your paper. Okay. Once you get it checked, just think that I received the paper on that same day. Okay, so I have not received your batches. 12s I have checked. So once let me get your paper, then we'll discuss. Okay, coming to the next one. Yeah, plus one thing. 54 kilometer per hour. Just apply one technique. Multiplied by 5 by 18 in one line, you'll get your answer. Rather than taking a bigger number, 1000 or 60 or dividing it multiple times, it's better if you take 5 by 18. So you have 54 by 5 by 18. This will give you the answer in just one line. What will be the answer here? This will be simply 15 meter per second. So 15 meter per second is the speed. So whenever you have kilometer per hour and you want the answer in meter per second, just apply this. Okay. So first step will be converting the speed into kilometer, from kilometer per hour to meter per second. And nobody is even going to cut your score. Why have you written 5 by 18 directly? In 11th standard, this is applicable. Like you can directly use it. Some of the things I mentioned, just mention this, mention that. In this case, you need not. So it says the driver takes 0.2 seconds to apply the brakes after he sees a need for it. This is called the reaction time of the driver. if he's driving the car at this speed, let's say the speed is 15 meter per second. I'm reading it as 15 meter per second because this is the speed with which he's moving. Brakes cause, what is this, class? Can anyone recall? We discussed it.
Negative acceleration.
Negative acceleration.
Negative acceleration, which is decreasing velocity. Okay, so we have to find out the distance traveled by the car after he sees the need to put the brakes. Means before the body is coming to rest, what is the distance traveled by? C class, distance during the reaction time is also needed here. This question says that reaction time is also there. Okay, when he was thinking, when he was applying the brakes, that time, this time was 0.2 seconds. So let's say he applied the brake here. At this moment, he applied the brake. Here, the time was 0.2 seconds. And one thing, class, I have been telling you, everybody, when you have the questions from uniformly accelerated motion, draw the things like this. A point, B point, like this. These questions were simple. If these are combined and they are made tricky, then you'll not be able to understand it, which quantity was from which part. Like here, there is a reaction time. There is a distance in this part. Here, the speed is 15 meter per second. So there will be a distance in this part. 15 into 0.2, that is 3 meters. Here, there will be a distance. Now we'll calculate the distance traveled while deaccelerating. There are two distances here. So draw these things. Nobody has drawn these things. See, it will
Ma'am,
cost.
I have.
Yeah, Maha has. Maha has drawn. Nabila and Hafza, you did. Draw these things like where the body is stopping, where is the acceleration. So it will give you a clear idea. Okay. Now we have got, this is 3 meter is the distance traveled by the car during the reaction time. Right. Now when this deacceleration has started, this part, let's say this is some final point B, this was some O point. Now when deacceleration has started, this 15 meter per second, this will act as the initial velocity. Right? This will act as the initial velocity. This is what we studied. The velocity with which it stopped in the first part will act as the initial velocity in the second part. And finally, he put the brakes. So final velocity will be 0. Now see, can you notice here only 15 to 0 means 15 to 0. That's why it is deacceleration, which is retardation. Okay, so you are not going to take this as 6 meter per second square. You are going to take this as A2 will be minus 6 meter per second square. It is deacceleration directly by yourself. Then use the equation v square minus u square is equal to 2as. Why are we using this equation? Because we do not have information about the time in this second part. Don't use 0.2 seconds for this deacceleration one. Okay. So this will be, this is 0 minus 15 square, that is 225, minus this will be 15 whole square is equal to 2 into minus 6 into the distance, right? So this will be 212 and 225 minus 6. So that is 12 into distance is 225. So this 225 will get divided by this 12. I think this comes out to be 18.75 meters. Just cross check it with your notes. I think this was the answer. Somebody just confirm.
Yeah,
Yes,
it
ma'am.
is.
This was the, okay. So this is the distance, but this isn't the total distance, right? The problem here is that what is the total distance? Total distance is the distance during the reaction time. That is your S1. This is your S2. So total distance will be 18.75 plus 3. That is 21.75. Okay. So here the total distance will be S1 plus S2, which is 21.75 meters. Please write this quickly, those who haven't, then we'll discuss the third one.
I had a doubt in the third one, like the second half of the question.
Third one.
Yeah, like I
Oh,
found the time needed to cover the first half, but in the second half I couldn't.
you couldn't calculate the time in the second half.
Yeah.
That will also be calculated through distance by speed only. Distance C, here when you will calculate, covers the last quarter. So it is 75 to 100 meters, right? So you have to check what was the speed before this. I think 10 meter per second was the speed. Just check in the notes. Okay, I'll explain this again, Maha, because the values I don't remember. I think it was 10. The speed was 10. So when you divide 25 by 10, it will be 2.5 seconds, Maha. I'll explain you this properly. Okay, the first half and second half.
Ma'am, how you got S1 as 3 meter in
That's
question
one.
number 2?
Speed is given as 15 meter per second.
That
Right?
distance 3 meter, that distant one.
Yeah, we are using the formula distance during the reaction time is speed into time. Okay, speed is 15. Time is 0.2. So 0.2 can be written as 2 by 10. 2 into
Okay.
15 is 30. 30 by 10, 3. This is like this. Distance is speed into time. What was the speed? He was driving the car at a speed of this. This is the common speed for both. Na? This was the final speed for this one and initial for this. So you use this. V will be 15 into 0.2. This is 3 meter. Okay. Just let me know done class. Then we'll discuss the third one. Done.
Yes, ma'am.
Hafsa and Ikra, have you written?
Yes, ma'am.
Okay, let's come to this question. Question number 3. Question number 3 is language is very tough because it says first half, second half, and you need to understand the timings and all. See, it's about a sprinter. Let me just discuss the question first. Okay, so see, this says 100-meter sprinter increases her speed from rest and uniformly at a rate of 1 meter per second square. So it means the acceleration is 1 meter per second square, right? And initially the sprinter is at rest. So one thing you know, sprinter runs the total distance of how much? 100 meter. Sprinter runs the total distance of 100 meters. What's the initial velocity? It's saying the initial velocity is 0 because from rest, u is 0. Acceleration is 1 meter per second square, right? It says up to 3/4 of the total run. Total run is 100, because it has mentioned that a 100-meter sprinter is there. So means she will be running a maximum distance of 100. So total distance is 100. 3/4 means divide 100 into 4 parts, right? 25, 25, 25, 25. Take 3 by of it, 3 by 4 of it. That is 75. So it says for the first 75 meters is the quarters and rest of it last quarter means 25 meters. This is 75 meters and this is 25 meters last quarter. Okay. Why? Because it is quarter means you have divided 100 into 4 parts. It will give you a value which you will be able to divide. Okay. Now for the last meter, it says she runs with a uniform speed, constant speed. Question has asked how much time does she take to cover the first half and second half of the run. Okay. First, we have to calculate the time to cover the first half. It has not asked us quarter. It has asked us first half. First half means how much distance?
50.
50. Okay. 100 is the total distance. First half will be 50. Second half will be 50. Half. Now we are not talking about the quarter. So first half is 50 meters. Simply use the equation S is equal to UT plus half AT square. It has
T
asked
will equal 10 seconds.
T will be equal to 10 seconds after solving this.
Yeah.
Okay. So see what all values you have to put. See, S, this is, let's say it is 50 meter. It has given 50, no? This is 50 meter, right? So S will be 50 meter. Initially, she is at rest. So this solves the problem. It's like 50 will be equal to half. Acceleration is 1, half into T square. Okay, 100, yes. Ma is right. This is 10 seconds. You get the time as 10 seconds. First part is very easy, right? In the second half, see, you have to calculate the velocity at, first you calculate the velocity at 75 meters. Then only you will be able to solve this question. Just do one thing, quickly write it till here, those who have it, the first part, then I'll discuss the second part. Just write it quickly, I'll write it here only.
Ma'am, which formula are we going to use to find the second half of the question? Because we can't use the 3 formulas, right?
No, we cannot
Because
use
the
the
answer
full formula. Exactly. We cannot use, we are going to use it. See, sprinter covers the last 25 meters at a constant speed of what? That you find out, that you tell me. What is this constant speed? Because one thing is sure that if she is moving with, okay class, listen, this is saying if she is moving with a uniform speed in the last quarter, means in the last quarter till the end, she is moving with 25 meters. So if you know what is the speed, that same speed will be applicable in the second half of the run, right? The sprinter, if she covers 25 meters, so we need to get what's the speed here. What is the speed? Tell me the speed at least by the time. This speed will be used, then this distance will be used, you'll get your time.
Can you use V equal to U plus AT?
Yes, we are going to use V is equal to U plus AT, exactly. So tell me, what is the speed coming? V is equal to U plus AT.
10.
10. Speed is 10.
Yes, ma'am.
T will be, yeah, U is 0, acceleration is 1, T is 10. So the speed also comes out to be 10 meter per second. Now class, see, you have the speed with you for the last part. The data for the second line was useful in this manner only. Otherwise, why will we require this last quarter? You know, the sprinter now covers the last 25 meters at a constant speed of 10 meter per second. This is here. Now the time taken to cover this distance, this will be given by what? We'll use the formula time is distance by speed, because initial velocity is 0. So anyways, that will be cut. So see, what will be T2? Distance is 25. I'm talking about the last quarter, this one. Okay. This one, last quarter is 25 divided by 10. That comes out to be 2.5 seconds, right? So 2.5 time to cover the time taken to cover the first half, that is 0 to 50 meter, was 10 seconds, right? Then it is saying first half is done, second half of the run, how much time does it take to cover the second half of the run? Now, first time we've already got, the person is in uniform speed till the last. That's what is meant by the second statement. So the time exactly to cover this much part, 25 meters, is also is 2.5 seconds. Now, what do you
But
want?
how, ma'am? But then it's asking the second half of the
Yeah,
run. The
that's what
first
I'm
half
saying.
is
This
50.
is, so for 25 meters, right? Now, second half means how much distance?
50.
50. Yes, 50, right? So it means for last 25 meters, it is taking 2.5 times, 2.5 seconds. So last 50 meters will take
2.5. So multiply by 2. So 10 seconds. No,
okay.
5.
So answer for the first one is 10, second one is 5. So this data was just helpful to calculate the 25 meters information because it has given you a value which can be multiplied by 2 to give you the value for the
Ma'am, how
last.
can you get time minus 10 seconds? 50. I
Uh,
don't know.
what Hamza?
How you get T1 as 10 seconds?
T1 as 10 seconds. This we calculated. If you put S is equal to UT plus half AT square, distance is given, right? Distance is 50
Yes, ma'am. Yeah, first half.
and this is 0.
But
So,
ma'am, first 75 meter, ma'am.
no. We are calculating it for the first half. First
Okay,
part we
okay.
were solving using directly because for first half we had lots of information. Initial speed was also there, acceleration was also there. So initially when you are calculating, we calculated it for the full one. Okay.
Okay. Then?
Distance was 50 meter. We solved the first part as it is. For the second part, we use this and doubled it. First part means you are solving this as it is. First half. 50 meter is the distance. And acceleration is 1. He will be this. Okay, one more question is left from you. Quickly write this and we'll discuss the last one.
Ma'am, can't we
Yes.
take like the whole from the 50 meters to calculate the time of the second half? Like the speed will be uniform, right? So the velocity will be same. Can't we just put
Velocity
10
is
in the places?
same from the last quarter. Yeah.
Yes. So we calculated that velocity, right? Like as tenths.
Yeah, 10 we have calculated. So you're saying
So can't we just do like 10 equals 50 meters by time and get t as 5 seconds?
this one, for this one.
Yeah.
Yeah, we can do that. You're saying speed we have as 10 meter per second and distance is 50,
50.
50 meters. Yeah, so initial, but do we know the final initial velocity is 0 or not? Actually, I did it with this because we don't have information whether when is this valid? When can we use directly speed is distance by time, this equation? When you know your initial velocity is 0, then only we use it na, directly. So you can use like in this question, you will get the answer directly. Time will be 50 divided by 10, you will get 5 seconds. But because from this also we know the answer is 5 seconds. Otherwise, just one thing, Maha. Here we don't know for the second half. Okay, yeah, finally the person is stopping or not, this is not clear. Right. But if it's 100 meters, the total distance, the person will eventually come at rest. It should be valid here. This you can use. Because see, initial velocity is 10 meter per second. That
Yeah, because
information
in the diagram I made, I put the last final velocity as 0.
zero, yes. Because see, through total distance is 100 meter, and it is saying a 100-meter sprinter is increasing the speed. So it's clear that after 100 meters he will stop. So with that knowledge, of course, this is valid. Otherwise, if we didn't know the last part, then we cannot use it directly. But yes, here it's valid, and see that's why the answer is also coming this way. You can use it like this. These rest of it we have discussed. Fourth one we have done it in the class, and the sixth one and the seventh one we have done it in the class. I think this total distance we didn't calculate. Maximum velocity till here we have done it in the class. Only fifth one is left. See. Let me discuss now. Those who have to write, just text me. Otherwise, we have one more assignment to discuss. This says an athlete runs the distance of 1500 meters in the following manner. Means starts from rest. So the person is initially starting from rest. Okay. He accelerates himself uniformly at 2 meters per second square. Till he covers a distance of 900 meters. Means till here 900 meters have been covered. This is acceleration one, this is distance one. Again, I think here also, Maha, you have drawn the figure.
Yeah.
Like, yeah. Rest of you, please start drawing it. Otherwise, it will be very difficult when
Ma'am,
the
I
question.
drew this question. I drew.
Hamza, you have?
Yes, ma'am.
Okay, good then. Please keep on drawing. Have a habit. Also, one more thing. Okay, I'll tell you that in free fall. So this is the acceleration. This is the distance. He then runs the remaining distance of 600 meter. Means whatever is left. Total was 1500, so 600 will be left. This one 1600 meter at a uniform speed developed. Okay, the question says you have to calculate the time. Last part, distance is also given to us. S2 is given as 600 meters, right? So you have the distance as 600 meters, 900 meters, total is 1500 meters. One thing we can calculate V. Here the velocity can be calculated. It is saying calculate the time taken by the athlete to cover the two parts of the distance covered. Also find the time when he is at the center of the track. Okay. So see, from here you will be able to calculate the time very easily. For the first half, use S is equal to UT plus half AT square. Correct? Distance is 900. Initially, the person is at rest. Yeah, starting from the rest. So U is 0. U will be 0. You have half, acceleration is 2 into T square. This will be 30 under root 900. First half will be 30 seconds, correct? Similarly, calculated for the second one. But in the second one, he said he runs the remaining at a uniform speed. Uniform speed means what's the acceleration? 0. 0. Uniform speed means acceleration is 0. Right? Constant speed, there is no acceleration. So in the second part, when acceleration is 0 means this term is 0. So we'll just get from the equation S is equal to UT plus half AT square. This whole term is 0 for us. Distance, we know it's 600. What's the speed?
Ma'am, we can
Yeah.
use that formula, right? Velocity equals distance by time for this by finding the velocity from the
Here
first half.
directly it will be because acceleration is constant. That's same thing. S is equal to UT. We'll get S is equal to UT only. Okay, directly you can use. So initially, okay, we have to calculate this final velocity here for the first part. Somebody please calculate and check what's this final velocity from the first part coming.
60 meters second.
60
60.
meter per second.
Yeah.
Okay. So you are going to use V square minus U square. V is equal to U plus 80. Any equation you can use. Yeah, V is equal to U plus 80. If you use 2 into 30 will be 60. So 60 into
Yes, sir.
T. So this will be 10 seconds. So total time will be 40. 30 plus 10. 40 आ जाएगा ना total time.
Yeah.
Okay. Now it is saying when he is at the center of the track. Okay, some of you got confused here. When he is at the center of the track means track is like this. This track is completely 1500 meter in length. When he is at the center of the track means half of the distance is covered. So 1500 is the total distance. Half of it will be 750. Right? So again, you're going to use the equation S is equal to T plus half AT square. This time, see, again, initial velocity is 0, but S will be 750. Half acceleration is 2T square. So time will be under root 750 this you can solve using long division method. You will get the answer. Answer will be this. Okay. Hafsa, the last question is clear. The fifth one.
Yes, ma'am.
Okay, you didn't share this one, or yeah, you didn't share, I think, this one now, Hafsa, from this assignment.
Yes, ma'am. I wrote, but
But you have not shared it. Okay, so just match it with your.
okay, ma'am.
Now we'll come to the free fall. One thing, Nabila, I have told you multiple times in the class to write about the sign convention. Your answer, if it is minus 3 meter per second square, so why would we consider, or why should I consider it to be correct? It will be correct only when you tell me the direction. When you have the free fall is all about the sign convention, right? Otherwise, it's not different from this.
Yes, sir.
Same equations we are using. So
Yes,
if you're not using the sign convention, if you're not mentioning what's your sign convention, straight away you will get a 0 in your answer. It depends on your teacher,
Okay.
but there are chances. So have a habit of writing this. Okay? I think.
Ma'am,
Okay,
what
ma'am.
does trajectory mean?
Yeah, that is in the free fall only, no? I think.
Yeah, the first one.
Ma'am,
I'll tell. Ikra, have you
question
understood
7.
whatever assignments we have discussed?
Yes, ma'am.
Okay. Hafsa, are you asking something?
Ma'am, question 7, I got 24 meter distance. I don't know. No, ma'am,
This
previous.
one?
Yes, previous assignment.
Question 7.
Yes.
Okay, we've done question 7 also. Question 7, we did it in the class.
Yes.
What's your answer coming?
24 meter. I know.
24 meter per second speed.
Not distance. How much
It is
distance?
saying a body covers 12 meter in second, 20 meter in for how much distance will it cover? 4 seconds after the 5th second. Okay, you're getting 24. Okay, I'll just check this. Rest of it we have discussed, so you'll be able to manage. If you still have any doubts from any of the assignments, please let me know. Okay, I'll just discuss this free fall part but you all should, other students should also have submitted the free fall topic. First question we have done it in the class itself. The fourth question also we have done it in the class, and the sixth question, this also we have done it in the class itself, simultaneous one. Okay, the rest of it which was not given, I have given as homework. See, the first question is very easy. The problem which you faced was in the trajectory. It says initial velocity is 20 meter per second. Height is given 25 meter. Now, see, I'm not writing everything in detail. Otherwise, we'll just be stuck on this. And only Maha and Nabila have attempted it. Maha's, this assignment was fully correct. There wasn't even a single mistake. Nabila, your answers were also right. It is that sign conventions were missing. Rest of you submitted. Trajectory basically means the path of the body. Okay, trajectory means path of the body. We have this trajectory term in motion in a plane. Trajectory of the body. Like if I have this pen, let's say, and this is moving like this. So this movement, this wave-like movement is its trajectory. If a ball is coming like this downwards, okay, ball is coming like this downwards. So this is its trajectory. Trajectory means if suppose a ball is there, this ball moved like this. You have thrown it, it bounced once, it tipped, and again like this, the ball went here.
So
this
basically
whole
the total distance?
not the distance. Distance is distance. Trajectory means what's the pattern of movement, path of the body. Like in this case, when the ball is thrown, it will be vertical. So like this, the ball will go, right? So that will be the trajectory. If the ball
like
was
that.
thrown like that, yes, the pattern of the body, not the distance. Distance is distance. Okay, distance, you have the term for distance. Trajectory means the path covered. Like we'll have a chapter, projectile motion. There the body has this path. This is often used for projectile. Like students who have must have heard in your school, this is what is the projectile motion. So this is the trajectory. Okay, that is what is meant by trajectory. Third question you were able to do, right? Third question, I think the equation only troubled, right? There was an equation t square minus 2t minus 8. This could have been solved using splitting the middle term. Something like this equation was formed for this, right?
Yeah.
You know? And then you had this fifth one. So here both of your answers were right. Here parachutist bails out of the aeroplane and after dropping a distance of 40 meter, he opens the parachute and deaccelerates at 2 meter per second square. See, class, here the initial velocity just has to be taken 0. The rest of the data is provided by the question. Acceleration is also given, okay? And you have to take acceleration due to gravity for the first half, right? And it is saying deaccelerate at this. Again, I'm saying sign convention is up to you. Whatever sign convention you take, just mention it. Because then only it will be corrected or incorrected. It can be marked. And what's the distance fallen is 40 meter. Use the equation v square minus u square is 2s. Time is not mentioned. You will get the speed, right? And then you calculate the distance fallen. So how will you calculate the distance which is fallen? Straight away you have the velocity, initial velocity, final velocity, acceleration. Or I think this question will be solved using this equation. V square minus u square is 2a. And you also have to calculate the total time, right? The total time also has to be calculated in this. So total time, once you have the initial speed, once you have the final speed. Class, if you, I think in this question, you will get the answer in roots because v square and u square are there. So leave your answer. Like I think it was
For
2,
the first time, it was 2 root 2 seconds.
2 root 2.
Yeah.
Okay, this was 2 root 2. Yeah. 2 root 2 seconds. Okay, yes, 20 root 2 was there, so that will be 2. Correct. 20 root 2 was there. So this will be, yeah, so you can leave your answer in terms of root. Like for the time, when you write this 2 minus 2 root 2 divided by 2. Okay, so just take the common, that will make it 10 root 2 minus 1. That's it. No need to solve this. Here you can leave your answer. Yeah, it is root 2. You can put the value 1.41 at the end if you are not short of time in your exam. But once you give your physics exam, you will realize time is not left actually in the questions. If you have time, you can put the value up till root 3, root 2. That's it. Root 4, you already know it's 2.
Height.
Yes.
Second part answer of 5 questions.
What
Question
height
5.
did he fill out?
Listen.
See, height, initially height, this is given as 40 meter, right? Then you need to calculate this deaccelerated height. From the second part, you will calculate this deaccelerated height. What is this deaccelerated height? How? That's what I was saying. Using this equation, you calculate the value of distance. V will be 2, right? Initial will be this 20 root 2. I think that's what Maha was saying. 2 root 2, right? And v square minus u square is 2. Acceleration is given minus 2 because it is deacceleration. So take it negative. And s. From here, I think you will get the distance as 199 meter. Somebody just confirm who has written Maha and Nabila from your notes. I think this will come out to be 199.
Yeah, yeah.
Yes, sir. I got
199.
190.
And when you add 40, so 239. Yes. So see, Hafza, here you have initial velocity as 2 meter per second. Okay. Then you have the initial velocity for this. This is when you have already solved the first part. Free fall part. Solve the free fall part, you will get the speed as 2 root 2. That is 20 root 2. Okay, for the first part. Solve it. How will you solve it? Initial velocity 0, acceleration 10 meter per second square, distance 40 meter. You will get the final speed. This final speed will act as the initial speed for the second part. Then you will have acceleration given as minus 2 meter per second square and speed final velocity is 2 meter per second. How? This is given 2 meter per second. Initial velocity you will calculate from here. Initial velocity for this will be the final velocity of the first one. That is this 2 root 2. 2 root 2, yeah, 20 root 2 meter per second. This will be. So from here you will get the distance. Okay. And then you have this distance 40 meter already. So height will be 239. Got it, Safsa?
Listen.
Okay. Similar is the final question also. See, you will, when it says average acceleration, first you use the equation v square minus u square is 2a. Yeah.
In some question, gravity is given 9.8 meter per second square. But in
Yes.
some question is not given, so can we take 10?
No, then you have to take 9.8. If it is not given, like here it has mentioned take this, and here also it has given. By default also, if it is not mentioned, you have to take 9.8 meter per second square because that's the actual value.
And what are
We round it off.
getting 10 root minus 1/4?
What? What?
What are you taking 10 root 2 minus 1 as?
10 root 2 minus 1 was the final time which I took, no? Like when you will have the T2's value, it will be 2 minus 20 root 2 by 2. So 2 I
Yeah.
have taken. Okay, so this is left. Put the value 10 into 1.14 minus 1, then total you can solve. Hafsa, we have actually taken 9.8, approximately 10 meter per second square. Okay. If there's a question you are very, very sure that will not be able to solve through this 10, still it's a suggestion to take 9.8 only, unless stated. In the question, it will tell you, take G as 10 meter per second. Okay, directly use that.
Okay.
So here also you will get the initial velocity. Step 2 will be calculate the final velocity once the ball rebounds. Okay, and then you have to calculate the average acceleration. Just one thing, this is what I wanted to discuss. When we are calculating the average acceleration, it will be v1 minus v2 divided by delta. So v1 from the first part, v2 from the second part, time is already given as 0.01. Is that clear? Now, those who have tried, they'll be able to relate. Those who haven't tried, you try it, share your answers, and then I'll discuss it in the next class. Because if I didn't discuss the assignment this time, then lots of assignment would have piled up. And at least tomorrow we don't have to discuss any assignment, so we can move on. See, when we have this velocity versus time graph, this is, I think, only left. This is only left from the velocity versus time graph. Rest of the graphs we've already completed. The position versus time graph we have done, and various kinds of slopes also we have completed from here. And I told you that when two things get divided, the third quantity is given by the slope of the graph, that is tan theta. Otherwise, we have, if two quantities are getting multiplied, the third quantity is given by the area of the graph. So I had to discuss this velocity versus time graph. See, when I have velocity versus time graph, let's say if I take the slope of this graph. So we know one thing for sure, that velocity is, or acceleration is dv over dt. This is very clear. Acceleration is velocity divided by time. If I take the slope of this graph, slope means tan theta. Slope ka matlab, just remember it's tan theta, whatever is the angle that is given. This is tan theta. This will give you acceleration. And how will you calculate it? If you know the angle, put it. If you don't know the angle, put value of v by time. And how do you put it? Just choose a point. Let's say I've chosen this point. Value of v from this, value of t from this, and divide them, you will get the angle, because it's a constant slope. So for every value you will get this. But velocity versus time is not just restricted to here. Why? Because when you multiply velocity into time, it gives the distance, right? Displacement. When you have velocity versus time, it gives you the displacement. So how to get this displacement? It will be given by area under the curve. And area under the curve means here, like you have a triangle, so half into base into height. This is what you should know, and you should remember for your entire 12th also. These things will be repeated. You will have various kinds of graphs. So that's what I've written. Slope of VT graph gives acceleration, area gives displacement. And this rule is not just valid for velocity versus time, it's valid for different kinds of quantities which have these relations. Now, we have acceleration 0, means slope is 0, and you want velocity to be positive. So from a positive value, I choose it, right? This is what? This is a constant slope. If v is negative, acceleration is 0. Acceleration 0 means no slope, 0 slope. So like this, because this is negative, here it was positive. This is how we plot the graph. Let's say one case. Acceleration is positive, means slope is positive. Don't relate graphical questions by their meaning, because with their meaning you'll not be able to understand in graphs. Graphs should be dealt with the terms of the graphs. Acceleration is positive, time is 0, v is 0, means this is starting from origin. Slope positive, positive slope from the origin. Like this is what we've studied. Or time is 0, velocity is negative, velocity is positive, some value, let's say here we have marked. Acceleration is negative, means you're getting a negative slope, right? So for this, I think in the previous also I have told you slope is negative.
You come
Slope,
from behind, right?
yes, you have to make it like this. So this makes an obtuse angle. Okay. And last case, I think, yeah, this is the last case. So time is 0, v is negative, a is positive. Now t0 means nothing will be marked on the times axis. V negative means velocity will be marked from here. But how will it be marked will depend on your slope. That is, acceleration is positive. So when you take the slope, it will be like this. Means you have the value of time for this particular value of velocity, which you don't know right now because the markings are not given. That's how we read the graph. But this will be the positive slope of the graph. Okay. From here, you are just drawing an acute angle. You can keep it till here also if this cutting is confusing you, but I think this shouldn't. This means that at this point, the value of time will be non-zero, where the value of velocity will be there. But that's not part of our question. Right now, I'm just teaching you how to plot the graphs. Is this much clear to all of you?
Yeah.
Okay, then write it. Then one question I'll discuss with you, and then I'll start with vectors today. Okay, unit vectors and all. Class, do you have any vacations this week? Because Eid is there, so anybody? Like any day off that we can have one extra class?
Thursday is a
I'm free
holiday.
every day.
Thursday? Every day?
I mean, like until Eid because my school hasn't started,
No,
right? I'm
Maha.
shouldn't it.
Your school has not started. Apart from Maha, is Thursday off for everyone? Because I have heard Thursday is also off.
Yes, ma'am. For me.
Yes, ma'am.
And Ikra, what about you?
Yeah, I only told that Thursday is a holiday.
Okay, yeah, you only told me. Okay then. So Thursday is off for everyone, na? We can have a class Thursday anytime in the first half.
No,
Or
I'm
even
not.
in
Mhm.
I'm going to
Maha, you're
India.
not. Why?
I'm shifting to India
On
on that
Thursday?
day. Yeah,
Okay. Okay, so the whole day you're not available.
yeah.
Okay then. Okay. Friday will be for you people. Saturday will be for me here. Sunday, is it off for you all? But Sunday will be difficult for you. Or is it? We need
Sunday,
to have extra class. Yeah, Ikra?
Sunday is also a holiday.
Sunday is a holiday. And so what about others? Are you people available on Sunday?
Yeah.
We have holiday till Tuesday. From Thursday to Tuesday.
Okay, Thursday to Tuesday you have. All right. Everybody has this
For us, so Monday school will be open. On 9th it will
Monday.
start.
So, Nabila, you there on Sunday?
Yeah. Yes, ma'am.
So I think Sunday we can have a class in the morning or any time.
Ma'am,
Because
tomorrow
Maybe
or
yes.
next Sunday?
next, not tomorrow.
Okay, okay.
Okay, not tomorrow, the next Sunday. Because there will be off here also, no? So you'll not have the classes in the evening. So that's why I want to take a 2-hour class proper, where we complete a portion, because vectors have to be completed. Then only your motion in a plane will be done. Once that is done, then your laws of motion and the rest of the chapters will begin. Maha, your admission is done.
Yeah.
Okay. In Hyderabad.
No, in a district, Mehboob in Telangana only.
Okay, Telangana. So Sunday, suggest a timing. Ikra, you only suggest, you have suggested the good days.
Not too early.
Not too early. Okay, not too early then. If it's just suggest the time. Tell me the time.
2 p.m.
2 p.m. Hafza.
Yes, sir. Going to Oman time.
Oman time means 1.5 hours difference.
Yes, ma'am.
That will be 3:30 IST. So 3:30 IST will be 1 o'clock for you all. है ना? KSA. It will be 1 p.m. KSA timings. Is this fine? 1 p.m. KSA on Sunday. Maha, you follow this one. 3:30. Just tell me a yes or a no in the chat box if you all are comfortable, or if you want any other timing, I am there on Sunday. Please let me know.
And can we do 4 p.m. IST?
Yeah, 4 p.m. IST can be done. 4 p.m. will mean half an hour shift. 1:30 KSA will be there. 1:30 KSA, 4 p.m. IST, 2:30 UAE timing. That is for Hafsa. Like everyone, are you all comfortable with this timing for
Yes.
Sunday? The next Sunday, not tomorrow.
Yes, ma'am.
Maha is there. Hafsa, you are available.
Yes, sir.
Ikra
Yes, ma'am.
and Nabila.
Yes.
Okay, then I'll have the class.
Ma'am, I have doubt in case 3.
Yes, yes, say Hafsa.
Ma'am, T is 0, so why you cross the line of T in...
See, you can, that's what I was saying. You can write it till here only. T crossing 0 means this is a value where you have the velocity as 0. At this point, this is a point where the velocity is 0. So this is some other case. You can stop it till here also, that is also fine. But when you'll extend it, you will get, when you extend the graph, in a graph is a representation about the whole scenario. So this is the point when the velocity will be 0. And at this point, whatever, let's say T1 is the time that is being represented. And when you extend it further, you can see something else. So this is how we read a graph. That's why I have drawn everything, but for just this case, T0 V negative, you can draw it till here also. That is also valid. But if you extend it, it's the same segment of the graph. So in the graphs, you can extend it also, and you can just mark it, because in a graph, you represent the whole case. If I have a graph like this, it doesn't mean the graph is still here. The graph has the extension still here. So you draw it till here, both are valid. So it is something like this, where the velocity is becoming 0. Okay, Hamza?
Okay. Yes, ma'am.
Okay. You all have done that till here. Okay, class, please try this question. Just try it, and I'm just coming in 5 minutes. I have to offer namaz here. This is the whole question. Please try it by yourself. 5 minutes, just give me 5 minutes. I'm coming, then I'll discuss it. Yes, class. See, for the displacement and distance questions, displacement, you have to consider the negative part also. Because in the case of displacement can be negative, right? In distance, you only consider the positive part. Now it is velocity versus time graph. So area under the graph will give you the displacement. So we have to find the area under the graph. First, we have a trapezium and we have a triangle here. So see, for the displacement will be equal to completely the area of the trapezium plus the area of the triangle. So area of a trapezium is half into sum of its parallel side into the height. So this will be half into, or you can do it like this also, two triangles here and then one square here like this. Half into sum of parallel sides. This is 2 and this is 6. So 2 plus 6 into, what's the height given? Into 10. Plus area is half into base is 4, right? And height is minus 10. 4 into minus 10. Now look, this is 8 into 5, right? This will be 8 into 5 minus this negative sign I'm taking, 4 into 5. So this is 40 minus 20, which is equal to 20 meters. So this is the displacement. But when I talk about the distance will only be the positive part. The negative part will not be considered because you won't subtract in the graph. So positive part means just the area of the trapezium, that is 40 meters. So the distance will be only the area of the trapezium. Which is half into 6 plus 2 into 10, that is 40 meters. Third part says acceleration versus time graph you have to draw. So see, you know the slope will define the acceleration, right? So see, how will you have? From 0 to 2 seconds, just mark the same things on the acceleration versus time graph also. Okay, same things you have to mark it on the acceleration versus time graph. So this will be now I'll have the markings. It is from 0 to 10. Yes, 2, 4, 6, 8, 10. So 0, 2 seconds, 4 seconds, 6 seconds, 8 seconds and 10 seconds. This is the time, and here we have the acceleration, and this will be the negative side. Now see, first part from 0 to 2. What is happening? Slope is increasing, right? This is, the slope is constant. This is how we check the slope. Theta will be constant everywhere. So constant slope and acceleration will be, constant slope will give you the constant acceleration, right? So here, when you have the velocity, see, here you have the velocity. What is happening to the velocity? Velocity is increasing. You're getting a constant slope. So we'll also have a constant slope till here, till this 2 seconds. Now let's see from 2 to 4 seconds. There is no change in velocity. Acceleration will be 0 in the second case. Acceleration will be 0 from 2 to 4 seconds. Let's see from 4 to 6 seconds what happens. 4 to 6 seconds, the velocity is decreasing. You get a deceleration, negative acceleration. See, 10 divided by 2, this will be 5, minus 5. Here the acceleration is 5 meter per second square. Let's say there's a value minus 5 meter per second square. So here you get the slope which is negative, right? But it is constant. So we have plotted the constant one. What happens after 6 to 8? Again, same thing. It is negative. right? And slope is constant. And what happens from 8 to 10 seconds? Slope is constant, velocity is increasing, so you get the positive value. So this will be this for the negative one. And what was there in 8 to 10 seconds? Yeah, 8 to 10 seconds. See, this is the value of velocity minus 10 to 0. It is increasing. So you get a positive value of acceleration, right? And the slope is constant. So it will be this from 60. This is how it will be plotted because everywhere you have the constant slope, all you have C. Quickly write down the solution.
Ma'am, can I ask you a question?
Yes, Havna, say.
If you don't mind. Ma'am, are you a doctor?
Are you?
A doctor?
I am a physiotherapist, Havna.
Oh, okay.
Why? What happened, Havza?
Nothing, ma'am. In your YouTube, now there's a neat qualified written, so that's why I just
Yes,
asked.
yes. Have qualified need.
Ma'am, can you scroll up?
Class done?
Yes, ma'am.
Okay, let's start with vectors then. Yeah, I've unmuted. Everybody has written? Okay. See, class, when we
New
talk
chapter?
about vectors, yeah.
Okay.
Yes, Afza?
I'm asking, is it your new chapter?
Yes, this is a new chapter. Chapter 3, I'm just giving you an introduction. We'll not be able to do complete much today. Tomorrow, I'll try to complete unit vectors with you because tomorrow we'll not be discussing any assignments, so it will give us a good time. See, when we have physical quantities, they are grouped into two categories. One group is known as the vectors, other group is known as the scalar group. Vector means you have the magnitude, there is a direction, and there are certain laws to be obeyed. These laws, we'll do it in detail. You have the triangle law, you have the polygon law, you have the parallelogram law. And magnitude, what is the meaning of the term magnitude? See, when I have written F is equal to 2 Newton due east, this means, this F means here, the force, which is what? Which is the physical quantity. Right? This is the physical quantity. Equal to sign 2 is what? 2 means without any sign. If this was minus 2, plus 2, whatever is it, without any signs, we write it as only 2. This is what is meant by the magnitude. Minus 3's magnitude is 3. Plus 3's magnitude is 3. So this is what is meant by the magnitude. When we say the term magnitude and direction, you'll use this often. And in class 12th also. Because vectors, physical quantities are there in your 12th also. Like force. Force you will study in chapter 4. Electrostatic force will come in 12th. So like this, you'll not be rid of this vectors topic. Integration, differentiation, and vectors will be carried forward in your class 12th also. So please have a good grip about the vectors. Motion in a plane will not come, definitely. But this chapter, vectors will, it's like the solving part of your entire calculation, a mathematical tool, kind of mathematical tool. So this is what is meant by the magnitude, means there are no signs. You don't write anything positive, negative. What is Newton? Newton is the SI unit. And this due east, this is basically the direction. So this is how we write a vector. And along with all these things, what do we have? We have magnitude, direction. Direction can be anything, towards the right. Even if I just say towards the right, that is the direction. Upwards, that is the direction. Out of the page, into the page, this is the direction. Towards positive x-axis, towards negative x-axis, this is also the direction. So in any form, towards north, due to east, like this, anything, these are all under directions. Then there are vector laws to be obeyed. When these three conditions are combined, then only we get a vector, which is like you have the example. Velocity and acceleration and displacement you have already done it in your second chapter. Displacement also you are now familiar, so we can put displacement, velocity, and acceleration. Force you will see in the next chapter, laws of motion. So velocity, force, acceleration, displacement. And what about scalar? Scalars have just the magnitude, no direction. You don't have any scalar laws. Scalar laws means algebra. For distance, we used to add it directly. Remember, distance and displacement, at least you all have done. For distance, how did we used to solve it? We used to just add all the terms directly. But for displacement, we had to be very careful. We had to put everything, velocity and acceleration. The whole concept of sign convention was because all these quantities were, well, vectors. Were they not vectors, we would have directly used v is equal to u plus at and all the equations, and we would have got the answer. But all these quantities are vectors and direction dependent. That's why you have so much emphasis on the sign convention. So when we have scalars, they just have the magnitude. You can just add them, subtract them, multiply, divide. No need of anything else. No quantity is required. You just have your algebraic laws applied. Speed, mass, distance, all these are the scalar quantities. Okay. And see, in some of the books, you will find the vectors represented by an arrow. This arrow symbol will make a quantity vector. Like I told you, use S for distance. Use S arrow for displacement. That's the vector. But class, in your some of the reference books, you will notice that this is written in bold also. If no arrow is mentioned and the quantity is written in bold, it means it's a vector. Like this, F with an arrow or the F like this. This is what is meant by vectors. Now, we'll be studying vectors in two parts. One is when vectors have angles between them. Two vectors are there, two forces are acting at 60 degree, two forces are there acting at 20 degree, like this. You have that form is called as the polar form. When you have the angles present. In the polar form, you have all these three laws, the parallelogram law, the triangle law, and the polygon law. These are all there in the polar form. Second form is the Cartesian form. Cartesian form means angles are not given. This is in terms of x-axis, y-axis, and your z-axis, which I told you once. Remember I cap, j cap, k cap?
Yeah.
The displacement question which we did, O2A, 2A, and 3A, that one. So Cartesian form means no angle is there. Everything is in terms of the Cartesian system. That is your answer. Okay. So this part, I'll start first with the Cartesian form tomorrow. Then we'll go to the polar form. Tomorrow, the whole time we'll go into Cartesian form only. You have the unit vectors and all. And tomorrow only, I'll give you time to copy this because now other students will start.